Alright, so time to make our graphs a little bit more defined. So we're adding intercepts. We've always added intercepts to all the graphing we do, x-intercepts, y-intercepts, and it's still, the rules still remain the same. If we want a y-intercept, we make x equals 0. If we want an x-intercept, we make y equals 0. So if I look at my first example, I start off the way we've always done it. Factor x minus 6, x plus 2 over x plus 2, x minus 1. I cancel, which leaves me with x minus 6 over x minus 1. And now, honest answer, you could find the x-intercept and the y-intercept without simplifying. It's just going to make your life easier when you do the simplifying first. So if I want to find a y-intercept, I make x equals 0, which in this situation, 0 minus 6 over 0 minus 1, negative 6 over negative 1 for 6. My y-intercept is 0, 6. So we're still plugging in x equals 0 the same way we do it for quadratics, the same way we do it for linear, the same way we do it for every single other thing that we find a y-intercept for. With the x-intercept, we make y equals 0. So we got x minus 6 over x minus 1 equals 0. Now what I like to think about is if I have a fraction equal to 0, no, I can make it a fraction equal to a fraction. 0 over 1. Can't be 0 over 0 because you can't have 0 in your denominator. So with this setup here, I can cross multiply. If I cross multiply, 0 times x minus 1 is 0. 1 times x minus 6 is x minus 6. So by cross multiplying, I get 0 equals x minus 6, which gives me in this situation x equals 6. So my x-intercept is 6, 0. Now the fact that we got the same x-intercept and y-intercept, that's a coincidence. That doesn't happen every time. Now if we look at our next example, if I factored x plus 4, x minus 3 over x plus 4, x minus 2, cancel, x minus 3 over x minus 2. Right, so if I want my y-intercept, I'm going to plug in x is 0. 0 minus 3, 0 minus 2, 3 over 2. My y-intercept is 0, 3 over 2. If I want my x-intercept, I'm going to set the equation equal to 0. Throw it over 1. I cross multiply. When I cross multiply, I get 0 equals x minus 3. I get x equals 3, making my x-intercept 3, 0. Now, one thing I kind of think about is shorthanding. I showed you this method. We cross multiply, we solve. Really, all we have to do is set the numerator equal to 0 and solve. Right, so if I had something like this, x minus 2, x plus 1 over x minus 3, x minus 4. From this example right here, I know this, set equals 0 solve, I have an x-intercept of negative 1, 0. I look at this, I set equals 0 solve, I have an x-intercept of 2, 0. Alright, going back to our original problem, making this more defined. If I want an x-intercept or a y-intercept, I plug in 0. So I have 0 plus 4, 0 minus 2, 4 over negative 2, negative 2. My y-intercept is 0, negative 2. X-intercept. I got x plus 4 or x minus 2. The shortcut method. X plus 4 equals 0. X equals negative 4. My x-intercept is negative 4, 0. So by doing this, now I have a vertical asymptote, a horizontal asymptote, a hole, an x-intercept, a y-intercept. So right here, I see this curve forming. It's obvious to me. It's going through there and it's going along that horizontal asymptote. Now we can plug in points into our x and solve for y situation. You could plug in 1, you could plug in 3, 4, 5, 6, 7, so on. Right? And in the end, we're going to get this piece right here. All right, so I'm not going to take the time to plug in those points. I just wanted to show you how to add the x-intercept, the y-intercept to this to make things more defined. So So compared to yesterday, where yesterday we had a hole and a vertical asymptote, now we have a vertical asymptote, a horizontal asymptote, a hole, an x-intercept, and a y-intercept. Will every single graph have x-intercepts and y-intercepts? Not necessarily. Right? If the horizontal asymptote is the x-axis, we can't have an x-intercept. If the vertical asymptote was the y-axis, we wouldn't be able to have a y-intercept. All right, so those are some things to think about.